I hope you're ready for this video because we're gonna do something never before seen. Probably not really, but so our interpreter is almost done. I mean, it is a fully working programming language now with first-class functions, classes, inheritance, and things like that. But we have one custom feature already, which is the pipe operator. Let's actually have a look at that. So it's in the parser. There should be, here we go. So we have this idea of a pipe operator, which looks like this. And what it does is it takes this thing on the right hand side and applies it to A. The reason I like that is because let's look in here. It's a couple of examples. Let's say I have a pipeline, a processing pipeline. And what I can do is I can say take some input data, then apply this function, then run another function. Okay, so that's very nice for these kind of pipelines and workflows. And I had this idea that maybe this language could be a language for writing automation scripts on the command line. So basically like an advanced form of bash scripting that also has classes and so on. And the way I wanted to achieve that is with a syntax that looks like this. So let's say you define something. I'm not sure if I want that. Let's remove that. So you have a variable name, an identifier rather, and then you have this arrow. Call it gets or whatever. So command gets, and then you write a command line thing. So let's say echo on the command line. So actually what happens if I run this? Echo on the command line. We'll just say on the, okay, so that works as I thought. Then this should produce a function bound to the name command. So then if I do this, actually let's write a semicolon. Then if I write command like that, if I call it, it should just say, actually what I would like is for the output of the command to be captured in a variable. So I actually want to say something like the result is this, and then we can print the result. And then we get something like that. So how do we achieve that? So if we actually, the first thing I want to do, or I need to do, is to go in here into the tokens, the token types rather, and we're gonna add a new character that we will call gets, and that's gonna be this one. Then up here in the scanner, if we find this character, then we need to check something like else if the next one is minus sign, then we should return gets. Otherwise we just assume it's less. Let me look at this one. Okay, so if it matches correctly, it also advances. So we could write a quick test. The test looks like this. Here we have some source code, command, gets, echo hello. We make a scanner on that source code, we scan the tokens. Then we assert on some things. First token should be an identifier, then it should be gets, the gets token. Then it should be a string literal. Then it should be a semicolon. And finally an end of file. And if I run that test, then you can see it passes. So now let's go into the parser. So if we want to keep this syntax that we just looked at, then once we pass, we actually end up in a statement. And there's no print keyword, there's no left brace, there's no if, there's no while, there's no return. It's just an expression statement. And it will consume an expression and it will try to consume an assignment. So I am a little bit worried about the conflict with this, but that we can worry about for another day. So if you match the equals token, it's just a normal assignment. But now if we match the gets token, then we need to do something. And we need to get the right hand side, and that can just be an expression. So I think this probably is, that's a little bit annoying. So okay, so let's get the right hand side. It should be an expression. And then we need to make a callable. So how is it we do that? This guy is a call. Actually, I think we have kind of a problem here. So I think this thing that we're doing now should be a statement similar to a function declaration. So if we go up here, okay, let me take a look at this one. Yeah, so this is making an expression. So we, how do we want to do this? Maybe we could make a new keyword. So actually let's we not do what do we want the keyword to be? Because I don't want to do like look ahead passing where that is not nice. So maybe we can just do this, because it is kind of a function that we're making, so at least it's consistent. So anyway, then we go, then we'll hit this one. So okay, we're making a function, we consume an identifier, then we have to actually go somewhere else. So we have to say if we are matching a gets token, then we need to return self.gets statement. And I think that's fine. So we'll make this guy. Okay. Actually, so we have the name, and this should then return, overall this should return a function. So let's say return okay, actually statement function, like down here, right? Name parameters. So the name is the name, the parameters is an empty vector, and the body is, let's call it command body. I don't know, maybe it should be, like a brand new type of statement. I think that's fine. So let's call it a command function. It has a name. There's no arguments. And then it just has, let's call it the command, which is a string. Then we go back to the parser. We're not going to return a function. We're going to return a command function, which has a name, and it has, so let's say, how do we consume specifically a string? By the way, this one we can remove. That was a bit too much. We can consume a token type. And is string a token type? Well, we have string literal, which is a token type. So we can actually say inside function, we can say that the command body is self.consume a string literal, and then whatever. This doesn't make any sense. Why would we unwrap? But we can do this. Let's see. Yeah, this one is called command. So what is this one returning again? It's returning a token. And what does the token have? Now I have to go check that. Struct token has the token type, has the lexeme, so I guess it's the, oh, we can take the literal value. I don't know, let's take the lexeme. That should be okay. And there we go. So now we have this specific statement. So now let's see, there's going to be a bunch of errors. For example, inside statement. Yeah. And let's check instead inside the resolver. Here it is. So actually, what do we want to do with this? It's kind of like a variable declaration, so let's treat it like that. And that should work. So let's say resolve variable, like so. See what else we can find. Something in the interpreter. And okay, so this is the fun part. Now we have a command function, and when that is being interpreted, we need to return a callable that runs a shell command, captures the std out, and returns it in a string. Something like that. So first, we need to make a callable. Now what is inside a callable? It's a name. It's an arity, it's a parent environment, some parameters, and a body. The body is a list of statements. So actually, I don't want to make a logs function. I guess maybe I want to treat it like a native function. Where is it we have that? Like here we have some native function. Yeah, a native function is just something like this, and we have an example of it in here. I'm just gonna get this for reference, and not in here, rather in here. Okay. Great. So we want to make a local function that calls to the command line. So let's do like that. And what's it complaining about? I can just remove that for now. How is it you make closures? Am I like losing my mind right now? Okay, the problem is this thing, and then this is wrong. It should be like that. Okay, great. Anyway, okay, after a lot of struggling with the borrow checker, I guess, here is the code. You interpret a command function statement like this. We have a name and we have the command itself. We need to make a local clone. Don't ask me why. It's basically to get the data out of this reference that we have up here. This is actually a reference to something. Then we move that clone into the closure. We need to clone it again so that the closure can use the data again and again and again. But anyway, we put that command into a command type from std process command. We get the output. We just forcibly unwrap it. Could be better, could be worse. Then we return the output as a string value. Then we create a function value out of that, which is a native function. and it has the name that it's been given, and it has this function. And then we define that function in here. So let's run cargo check again. Nothing there. Let's take a look at this one again. So if we run it, cases, echo command, what happens? Expected. I wonder. Like, what the hell? So is it up here? Yeah, it's for some reason it's not. So it should be in here. Consume a string literal. And that's fine. I don't know what's happening. So let's consume a semicolon. Do that. Run the same command again. So where's it saying that? Expected. Ah, so in the variable declaration. And why? Let's get rid of that one. Inheritance within it. I thought I had killed you. Anyway. But it is for sure complaining here. All right. So let's try to think about what the parser does. Gets a declaration. There's no var token, so we should hit this statement. Ah, now it's because we had actually changed the syntax, and it should look like that. And now it's saying expected expression, and I have no idea where that is coming from. It's coming from in here, which is the parser. Okay, fair enough. So we should go here and we should say parsing gets. That works. Say command body is that. Command body is a token, stringlet, which has that lexeme, which has a literal and some line number, whatever. And then we will consume a semicolon. Run that. Okay. Now we have another problem. The resolver, which has to do with this hack we did, most likely. So let's go in here. Yeah, so it's actually not supported. So let's say if it is a command function with a name and a command, which you probably don't need, then we do something and we will do declare of the name and the define of the name. There's no need to, there's nothing in the command we can resolve. So what is it now saying? It is saying something, 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 because I need this. Right, okay. So then we need to go here and let's change this unwrap because I have a suspicion that this is where it's happening. Let's change this to an expect and we'll say failed. We'll say fail to run command. So let's run this. Panic at fail to run command. And it doesn't like what we have given it. And the reason is, so let's say command.clone and let's say command is a command with new. Okay, so how do we split? Do we have any of that in this project? Yeah, we have this one. So you can say command.split maybe. And this one will have the first part. And then we can say for exactly. And this one has to be mutable in that case. Okay, so what we're doing is we're taking the command, we're splitting it by white space. The first part is the name of the command, the rest is treated as arguments. And then we can finally say that the output is the output of this command, and we'll say fail to run command. Now I'm also a little bit worried that this will not work, but let's try. Fails again. So let's try actually a simpler one. So we'll call echo hello. So for some reason it's still failing. So what I want to do is to check what we did in here. So not sure what that is. What does E mean? Okay, I have no idea what that means, but it should be relevant. Can we print this? Yeah, running command, that thing. No such file or directory. What? Cargo run E, so that was wrong. We need to say, okay, running command echo hello. And what's with this escaping? So something clearly went wrong. Command was something. Command was echo hello. That's great. And what is the parts? Is it exactly. So something funny happened here. You know what? I think the problem is Not that. How do we pass a string literal? Yeah, so the problem is literally this weird escaping that it's doing, which is really bizarre. So can I do replace? Yeah, that. And the same here. Let's see if that works. And it's also making a new line, which I guess is fine. But that means we need to fix up here. Something like that. Now let's run the tests. Yeah, and also there's a test here that's failing now. Right. Because this has to be 6 now. Then we have to make another one of those. We have to increment. That didn't work as I had imagined. Why does it do it like that? 1, 2, 3. Okay. Never mind. Right, and what is this fun thing? It's just fun. Now the test passes. Now everything passes. So now we have a scripting language where there is built-in support for command line stuff. So I think that's pretty cool. So here's just a fun example of what you could do. Let's define a command where we grep for the word grep inside of this file that we're in. And that should actually return this line. So let's put that line here, and then there's the extra new line. So let's run that. And well, now we have a kind of a problem that I didn't think about, that it will also produce this line, but then if we put that line, it will now produce that line as well. So there's actually no way we can make this work. So let's grep for result instead, and that should just give us those 2 lines. And the extra new line. And now it will, no, it doesn't work no matter what you do. Okay, we have to grep some other file. We will grep the echo command thing. And we'll grep for result. And actually it should be that as well. So let's try to run that now. Okay, that's worked. So let's run the tests. And it failed. It failed. This one. cases, self. It's funny, when I run it here, it works, but when I run it here, it does not work. Okay, so that has to do with how variables are captured or something. When we run it, we can see it works, and that's gonna be enough for now. And that's it. There you have it. We just invented Bash 2.0. See you in the next one.